Here we are at example 12 from the 0.2 number 2 set of notes. We're asked to graph this rational function. Now the beautiful thing about this is that everything is actually already gone ahead and factored for us. So we notice this x plus 1, there's 1 on top, and there's also 1 on bottom. We can go ahead and cancel those out. This x plus 3 can just simply cancel with this x plus 3 on the bottom, and so our final function that we have, f of x, is actually just equal to -3. And as a result, what we should be seeing, since there's no x's at all here, is pretty much just a straight line kind of going like this at y equals -3. Now, again, when we're talking about finding those holes, you still set this bottom not equal to 0, just like normally. So we have this x minus 1 is not equal to 0, and that x plus 3 is not equal to 0, much like we did with our vertical asymptotes. From here, all we do is go ahead and solve for each one appropriately. So this will just come out to be x is not equal to +1. Over here, when you subtract 3 from both sides, you get x is not equal to -3. So we see some holes at 1 and -3. However, there's an issue. When we try going ahead and plugging back these into our new function, well, there's no x here. Oh no, what's going on there? Well, again, a moment ago, we said that this would just be a line happening at -3. So we can go ahead and just graph that line at -3. So here is that line. There are no vertical asymptotes because literally everything canceled out, so that's kind of nice. But there are, in fact, holes at, for example, this specific x value. At x being 1, well, according to our function, it's -3. There's actually existing a hole here. So I'm going to go ahead and just erase a little bit of area right here. And so we should see a little hole still right there. And our function is actually still also connected to him. So that is what you should actually end up seeing. Notice it's still part of that function, even though there's no x value to really plug into that function. We're still allowing kind of that smooth y is equal to -3 line. Now to take care of this -3, it's actually the exact same thing. So we're just going to go over -3 for our x values. It has to happen with this line, cross through that line. So we're going to go ahead and erase a little bit just so we can squeeze in that hole. And just kind of connecting it from each side. So this is actually what our graph would look like. Notice this is what we said in the example 12 video, or I'm sorry, the example 11 video. That is that removable discontinuity. It is discontinuous because you kind of see this jump due to the holes. So again, that's why it's discontinuous. So notice there's actually this removable discontinuity simply because there is that hole there, and you do see this kind of jump in the graph. It actually happens twice in this one. So that is, again, what our image looks like. And this is, in fact, what our line is. Y is equal to -3 when we kind of simplified things. And just one last thing. Because we found that x value, it's at 1 for this hole. We have the hole happening at 1. The y values are always going to be -3. You can even see it on the graph. It's always going to be -3. So we should see a hole here at 1, -3. That's where this hole is. And then the other one at -3, -3. So again, these holes are actually specific points. Notice, in fact, it's literally a point. So again, that is example 12 from the 0.2 number 2 set of notes.